Hi, in this video we're going to talk about how do you find the absolute value of complex numbers. Absolute value of complex numbers. So I'm going to show you how to do this by using the formula and also what it actually means when you say absolute value of a complex number. So the absolute value, it's denoted by two lines like that. When you put it inside two parallel kind of lines like that, it's called absolute value of z. So the absolute value of any complex number of the form a plus bi, the formula is this: it's equal to the square root of the real coefficient square plus the imaginary coefficient square. That's all you have to do. So for this problem, to find the absolute value of the complex number that we have here, our complex number is 3 plus 4i. So all we have to do is take the square root of 3 square plus b is the coefficient of the I, which is 4, so 4 squared. I would always prefer to put the parentheses like that before you put squares, because if you have negative numbers, that would help. So there you go. So in this case, we will get the answer as 3 to the second power is 9, and 4 to the second power, 4 squared, is 16. So we get a total of 16 plus 9 is 25. And the square root of 25 is 5. So that's how you find the absolute value of any complex number. What it really means, absolute value just means how far is this complex number from the origin. So if I were to plot this complex number on a graph, I would go, since it's positive 3 from the center, I would go 1, 2, 3 to the right. And since it's positive 4i, on the imaginary axis, I would go 1, 2, 3, 4. So this is where the point is. This is where z, which is 3 plus 4i, is at. That is the location of the point on the complex plane. So how far is the distance? How far is z from 0, from the origin? This distance is what we found out to be 5. This distance is 5. So you can also do this problem by applying the Pythagorean formula, because if you just complete this triangle right here, it just becomes a right triangle, and this length is 3, which is the real part, and this length 1, 2, 3, 4, which is the imaginary part. So all you have to do is apply the Pythagorean formula. We know that c squared is equal to a squared plus b squared in the Pythagorean formula. And we just apply that, and we get c is the square root of a square plus b square here. Here the legs of the right triangle are 3 and 4. So to find c, you would just find the square root of 3 square plus 4 square. Again, which is 9 plus 16, which gives you 25. And the square root of 25 is just 5. So you get the same answer if you apply the Pythagorean formula also. But if you just want to do the absolute value of regular numbers, you just apply this formula right here and you get your answer. So let's just try one more question here. Here it says find the absolute value of z1 minus z2. And z1 is given to be this complex number and z2 is given to be this complex number. So if you want to find the absolute value, first you find what's inside the absolute value here. You find what is z1 minus z2 first. So z1 is 1 plus 18i. So z1 minus z2 is 13 plus 18i. So all you got to do is distribute the negative sign inside the parentheses here. So you get 1 plus 18i minus 13 minus 18i. So when you combine the real numbers with the real, 1 minus 13 is negative 12. And then when you combine the imaginary with the imaginary, you get positive 18 minus 18, which is 0. They just cancel each other. So you only have a real part for this. So when you find the absolute value of z1 minus z2, which is supposed to be the square root of the real part square and the imaginary coefficient square, we really do not have an imaginary part. So it's just like 0i. So our a here is negative 12 and our b is like a 0 because we don't have an imaginary part. So this just becomes negative 12 squared plus 0 squared. So negative 12 squared is 144, and the square root of 144 is 12. So that's it. That's how you find the absolute value of complex numbers.